we've got a solid architecture set up for our team that will allow them to develop their applications, deploy new ones, scale to their heart's desire, and monitor everything easily. So what's next? Where do we go from here? How can we grow and optimize our architecture more so? Well, this is where the architectures are going to start deviating from each other. Where we are right now with our architecture is a solid and scalable platform for 80 to 90% of applications and services. However, as your traffic picks up and as your application and business evolves, the changes that you'll need are, well, they're going to differ from what another company might need. So, just an example, the changes that, say, a video streaming company needs, those are going to be different from that of a machine learning research one. Though both will have applications and services that are, that largely use what we've done as their foundation, the extras to take things further, well, those are going to be different. Video streaming is going to prioritize, queues and streams to encode and deliver video, whereas machine learning, well, they're probably going to be more concerned with services like AWS SageMaker and reworking their applications to use the GPU specialized EC2 instances. And if none of that made any sense to you at all, the long story short is that next steps for your architecture are going to depend on your company and product. That being said, there are some common optimizations that you can do to make this foundation better. And just to give you some ideas, first up would be query caching for your database. Whatever you're building or whatever industry you're in, the database is always going to be one of the biggest bottlenecks. Now, granted, AWS Aurora has made some incredible strides in terms of speed and availability, but the bottleneck is that data, of course, must always be correct, unified, and in one place. And so you can have thousands of users on your app that have tens of thousands, if not more, queries hitting that one database. And by queries, I just mean requests for data. Well, think about any given user interacting with an application. How much of the data that they're consuming changes? Well, if it's something like a spreadsheet application or a bank account, it probably doesn't change that rapidly, does it? And I don't just mean like figures or numbers. I mean things like the user's details, account details, things that just don't change a lot. Even if you're making a social media app, just like we just said, the user's basic details won't be changing frequently. Well, even though they might not change often, every time that user logs in, well, the database is still going to get hit with a query for that information. And so what we can do is we can use things like AWS Elasticache and Redis to cache common queries. So maybe your application has a weekly summary of things that happens to show up on a dashboard. Well, even though that's not changing because it's just last week's events, every time the user compulsively checks the application, because they're going to do it, your database is going to get hit. And so what you do with something like Elasticache is that after the database is asked for whatever data your app needs to show for this weekly dashboard, we save the results of that request into Elasticache. And now when people come back to the dashboard again, instead of having to go bug the database, well, we just ask Elasticache for that data. And by the way, this will make things much faster because Elasticache and Redis, instead of keeping those saved results directly on disk, so on hard drive, like a slower hard drive, they keep them in the much faster random access memory of their host machine, which means grabbing the results and returning them is far more performant. Okay, so the next optimization you can do is also database related, and that's read-write splitting for your database. First up, it's important to understand that a database is not just limited to one instance or server. Same thing, right? So for example, in AWS RDS Aurora, you can have one master database instance, but you can also have fallback and read-only database instances. Now those fallback and read-only instances are all connected to the same store of data as the master is. However, the master tends to be the only one that writes the data. Why? Well, because to keep things consistent, we don't want 3 or 4 of our database instances trying to write updates. They could get in each other's way and wind up corrupting the data. And so the problem pops up where the master database instance is going to get hit with both write requests and read requests, which is going to slow it down significantly. And so what you can do is split those queries up. You can make it so that only write requests go to the writer and only read requests go to the readers. And if you think about it, this is going to speed up significantly. It's going to significantly speed up the performance of your application. The writer is going to have more compute to execute its commands faster, and the readers will be able to return the data faster. And the other reason that this is a big split and you're going to have more readers is because if you think about any given application, you spend more time reading and asking for data than you do inputting it the majority of the time. Now, in terms of going about this, there's really 3 options here. The first way is to use tools like Proxy SQL. Now, these tools are something that you install on a server and you put in between your application and the database. And then when a query comes in, it will intelligently split the traffic to the reader or the writer based on the query. The second way is to implement it at the application level. This would be telling the different parts of your code when to go to the writer and when to go to the reader. And the third way is hoping RDS implements it, and this is kind of a joke, but they're already stepping towards this. As it stands, right now AWS RDS database clusters, because again, they are groups of instances, so clusters of instances, they give you a single endpoint. So just a single URL, not really a URL, but a MySQL endpoint, right? A connection string for writing, and they give you another separate connection string for reading. And the cool part is that when you have, say, 2 or 3 readers, you still only have one reader endpoint. And when you send read requests to that one endpoint, it will load balance that read request across those reader instances for you. And also they've added the ability recently to turn multiple instances into writers, so masters, which is a major step in this direction and being able to just sort of send reads and writes wherever you want without having to worry about this at all. Okay, so the third thing, and prepare yourself, is offloading small logic to lambdas. Okay, so you've probably heard of the term serverless at this point more than Coca-Cola, and yes, AWS Lambda is a useful service. However, it's still coming off that buzz point where everyone wants to use it for everything. And quite frankly, a lot of it comes from the confusion of marketing labeling it as serverless. As you can guess, this creates all sorts of confusion regardless of where you are, right? If you're an ops, you're going to see that term and be like, I don't know what's going on. And if you're like, say, a front-end developer or a web page designer, you're like, oh, sweet, now I don't have to learn servers. But let's go ahead and let's take to figure out what it is. What it truly is. Let's look at the normal process of writing applications. And that is usually to what? To write the application, which may be a massive code base, configure the server and put the application on it, and then direct traffic to the application. Well, with serverless, what you do instead is you're going to write a function that can be called to do stuff for you. So just one single function. Maybe you write a function to ping a third-party API or something that helps out with a computational task. Either way, the first thing you do is write a function. After that, you hand the function to AWS Lambda, configure it, and in return, you get an endpoint for the function. When you want to use it, well, you just call the Lambda and it'll run the function code you wrote. Now, these functions are generally kept small. And by the way, and this is where people are going to lose their minds and like just bliss almost, but because they don't read past it, you're only charged for when they're executing. Now that is the big selling point on Lambdas. They don't sit there and wait around, and this can lead to savings because, well, applications on a server, those are going to be running even if you're not using them, unless you set up some sophisticated cron jobs to make sure that they go down at the right time. For the most part, they're going to just keep running, but Lambdas will only be running when they're called upon. Now, aside from cost savings, it can potentially, I'm doing double quotes in the air here, save you time with some more double quotes in the air here that would otherwise go towards configuring servers. But, and this is a huge but to keep in mind, there is a lot of other configuration you have to do for Lambdas. Sure, you're not going to be messing with Linux or operating system configurations now because we're serverless, but you are going to have to configure a number of other services in AWS to get it working, like API Gateway and a number of their other things to make it so that you can even reach that Lambda, use that Lambda, or give it permissions to do anything. And so though people will say that it saves you time from configuring servers, it really only saves you time from understanding servers. It'd be kind of like saying, well, by going to eat this ham sandwich, you won't have to eat this hot dog. Okay, great, but you're still eating something regardless. You're not just getting out of eating something altogether. Well, the trade-off here is, again, you gotta learn how to configure the Lambdas, right? Much like configuring a server, this can be very easy for small things, but stupidly complex for larger things. So the time savings benefit is kind of a moot point. You may not have to learn Linux and everything about a server, but you will have to learn everything about configuring a Lambda on AWS. But I don't want it to sound like it's completely negative. For smaller side tasks that you don't always need up and running, something small and temporary like a Lambda can work wonders. That is what they're for. That is what they're great at right now at the present time. Okay, and lastly, use infrastructure as code. If you're getting into cloud development and architecture, this is the end game. Because what if I told you that everything we talked about could be done in code? Well, think about that. That's a powerful idea. That means we can version control it, easily review it, and have far less worry about disaster recovery. Well, that's what tools like AWS's own CloudFormation and HashiCorp's Terraform allow us to do. Instead of clicking around in the console or sifting through tons of command line interface commands, you can just write out everything you want and how it's connected in code, hand it to AWS, and have it deployed automatically. Folks, I can't explain the number of times using infrastructure as code has saved me time. It's not as if you're making full infrastructures every day, and so if you come back 6 months later and need to set up a new one, well, hopefully you remember everything and hopefully you don't make any mistakes. On the other hand, with infrastructure as code, if you wrote it and it worked once, well, unless someone's playing a prank on you and changing things behind your back, it'll work identically next time. Now, if you're interested in learning more about infrastructure as code, we have our free CloudFormation Fundamentals series that I'll link to below the video. It'll get you up to speed on all the major concepts through a simple technical project. Okay, while we could keep going here, these are the next major optimizations I do if you already have everything else done.